Hi everyone, let's solve the third question from weekly contest 326, that is partition string into substrings with values at most k. So we are given a string s which consists of digits from 1 to 9 and an integer k. So partition of a string s is called good if each digit of s is part of exactly one substring, right? So whatever substring we form, right, there should not be any substring with overlapping values, right? So for example, if we have this substring 165462, so we can have 165 and we cannot have another substring 546. We cannot divide it in such a way. So we have to make sure that each and every digit of s is part of exactly one substring only. And the second condition being the value of each substring is less than or equal to k, right? So what is the value of each substring? So for example, here we can see 165462. So if we consider 16 a substring, so whatever is the integer value of 16, 16, so that is 16, right? So 16 is the value of that particular substring. So let's say if we take 165 inside of the first test case, then 165, its integer value is 165. So that is the value of that substring, right? So the value of each substring should be less than or equal to k. So then we have to return the minimum number of substrings in a good partition of S. If no good partition of X exists, return -1, right? So this is the question. So we have a string, right? And we have to divide it into some good strings. Now what is a good string? A good string has a value less than k, right? So if we consider 16, so is 16 good string? Like if we consider 1 here, okay, let me erase this. If we consider 1 here, right, so 1 is a substring of this string, right, and 1 is also less than 60. Its numerical value is also less than 60. So that means 1 is a good substring. If we consider 16, is 16 a good substring? Yes, it is, because its numeric value is 16 and it is less than k, that is 60. So it is also a good substring. If we consider 165, is its value less than 60? No, it's not. So that means this is not a good substring, right? 165 is not less than 60. So this is not a good substring. So that is what we mean by a good substring. Now we have to divide this string S in minimum number of good substrings, right? So let's see. If we have 1, so we can have good substrings 1, 6, 5, 4, 6, 2. All these values are less than 60, right? But these are also good strings, but we have to minimize this number. We have to calculate minimum number of good substrings. So how can we calculate minimum number? So that has to be like, if you go from 1, then take the next element also, 6. Is it less than 60? Nice. Take the next element. It is not. So that means 16 is the good substring. Then we come to 5, right? From 5 we will calculate. From 5 we will go to 4. 4. 5 is also less than. So we moved on to the next element, that is 5 and 4. Now we have our substring as 5, 4, which is also less than 60. Then we move on to the next element, that is 6. Now 546. Is it less than 60? It's not, right? So we have our string as, so another substring that we form is good substring, that is 54. Then we will move on to 6. Is 6 less than 60? Nice. But can we take another element? 2? No, we cannot. So our substring is limited to 6 only. 6. Now the only element that we are left with is 2. So now this is also a good substring. Like all these strings are good substrings, and as they are less than 60. And this is the minimum number of substrings that have value less than 60, right? So how can we determine that we have minimum number of substrings? So the thing is that substring is a contiguous sequence, right? It is 1, 6, 5. It is a substring of this string. But is 164 a substring? It is not, because it is not a contiguous sequence. We have 1, 6 and we jump to 4. But if 4 was just after 6, then it would this would have been a substring, right? So this is not a substring. Substring is a contiguous sequence, right? So we can, if we traverse from here, so what how do we minimize the number of good substrings? So wherever we are in the string, we will try to take the maximum numbers from that part, right? As we saw, 1 is a valid substring, but if we add another element to it, that is 6, is that a valid substring also? It is. So we will keep adding until it is a good substring, right? Until its value is less than k, right? So this is I hope the question is clear to you. Now let's see how we will solve it. Now this question can be solved using binary search. Let's see how we will apply binary search to this question. So as you can see, just a minute. So we have this substring, right? How many parts of this substring can be done? So the minimum substring that we can form from this string S is 1. Why? Because if we take the whole string, it is also a substring of S. So minimum is 1. How many maximum substrings can be formed out of it? So if we consider each and every element as a substring of this S, right, then these all individual elements are also substrings, right? So if we consider them as substrings, so the number of substrings that we will have in S is the length of S only, the length of the string only. That is the maximum number of substrings we can have. So how we will apply binary search? So we will apply binary search in this range, right? So we have a range 1 to length of string. We have this range, so we will apply binary search to this. So now what will we do in binary search? So we will take a part, right? So let's say we have 1 plus, what is the length of this? 6, right? Divided by 2, it is 3. So we will consider, let's say, we will consider that we can divide it into 3 substrings, 3 good substrings. So then we will make a function called isFeasible that will actually check whether we can form 3 parts of this string or not. So let's see the idea behind that function. Okay, so here what I am doing is, as we discussed, first of all, I am converting this string into a vector of int, right? An array of integers, because that will make our calculations easier, right? Then we are calculating the size of this vector inside of n, right? So then we have low, as we discussed, the range will start from 1 to the size of the string, and this res variable is the result variable, which currently have -1. So let's say if we don't have any solutions to this string, for example, if we consider this second test case where we have 2 3 8 1 8 2 and k is equal to 5, as you can see, 8 is, like, if you consider 8 as a substring of this string, it is greater than 5, right? So when a element is already greater than 5, so we cannot consider it a substring, right? Oh, sorry, a good substring, right? Because 8 is greater than 5. So there is no way that we can divide it into number of good substrings, right? So let's come here. So we have a result as -1. So we have to return -1 if we cannot divide a string into good substrings, right? Then we are applying binary search in this low and high range, right? That is 1 and to the size of the string. Then we are calculating mid, and we are, for each and every mid, we are calculating a isFeasible function, right? To check whether that, if the number of parts that we have taken, is it a feasible solution or not, right? So for example, here, as we saw, the answer to this question is 4, right? We know it right now, but let's see. So after first iteration, that is 1 plus 6 by 2, we will get 3. So we will call 3 for this, right? So let's see what isFeasible function does. It takes the array and the n and parts, that is the mid value, and sum is the k, right? Now we are taking the first element of this array into num, and we are taking part. So part has to be 1, right? So we have to consider part is equal to 1. Now inside of this loop, what we are calculating is the value of num, right? So what we are doing is we have 1 and 6, right? But how do we tell it the value is 16? So we have to multiply this 6 by 10 and we are adding 1 to it. Sorry, I said it opposite. We will multiply 1 by 10 plus we will add the current element that we have in this array. So we will get 16 from this line. Now we will check if this 16 is greater than sum. If it is greater than sum, then update num to that particular array element. Update num to that particular array element. It is not right now. So when we will have 165, so what we will do? We will update num to this 5, right? So this is our one substring. So we will do what? After our sum exceeds, after our number exceeds sum, we will increase the number of parts here, right? And in case num becomes greater than sum, right? That is any array element, any individual array element. That is the case, right? When we cannot partition the string into good substrings. If any individual element becomes greater than sum, that is the condition, right? So at that condition, we will return false. Otherwise, we will increase the part and then we will iterate again and we will keep checking, right? We'll keep checking, and at this condition, we will break and we will update that particular element. And in the last, we will check if the number of parts, how many times our sum was exceeded, if that becomes greater than the parts that we got from the binary search result. If it is greater, then we have to return false. If parts are less, then that is a feasible solution. So that is how we are checking, and that is what this is feasible is doing. So right now, let's implement it here. That is, we are given this string s. We have 165462 here, right? So we got 3 here, right? So according to our is feasible function, we have passed 3 to that is feasible function. So we will calculate num as 1 right now. It is 1. Now we will traverse in this array, right? We will traverse in this array. So the array we have is 165462. So we will traverse in this and we will calculate, we will update the value of num to 1 into 10 plus 6. So we will have 16, right? So we have not yet fall into that case, right? Then we will iterate again. For the next I we will check. Now num will become what? 16 into 10 plus 5, which is 165, right? Now if we check this condition, that is if num is greater than sum, which is true, num is greater than k, right? So num is greater than k. So what we will do? We will update num to that particular array element, that is 5. And also we will check if this 5 is greater than k, right? For this second test case we saw, right, that if 8, let's say we reach to 8 and it becomes greater than 5. So if any individual substring, any individual element of this string is greater than the k, then there will be no partition. We cannot divide that string into good partitions, good substrings, right? So it is also true. So we will move forward and we will increase our part plus plus. Now we have 2 parts, that is one part is 16 and the other part that we are considering is 5462. Now we will see if this has to be divided into parts. So we will begin from 5. We will begin from 5 and similarly we will calculate 54, right? Then again our part will be increased to 3. If we come here and if we will come here, our part will increase to 4. Now if we check the last condition, we are saying that the part should be less than the parts we have received from the mid, right? So mid element was 3 and this condition is false. So this will return false. So what we have to do? We have to move towards the right part of the range, right? Our range was from 1 to 6. Our range was from 1 to 6. So in first iteration we had got 3, right? So now we will update from 3 plus 1 2. We will go to high, which is 6, right? So we will calculate 4 plus 6 by 2. What we will get? 10 by 2, that is 5, right? So again we will check for 5. For this condition, as we saw, our parts were 4, right? For this condition, this is feasible function will pass. So our rest will contain a value of 5, that this is a feasible solution. Now what will happen? We will move toward the left part of this range. What is the left part? We will move to 4, 4, right? So if we calculate 4 plus, if we calculate mid, we will get 4 only, right? So after we go inside of the is feasible function, we will pass this also, because 4, we can do 4 parts of this string, right? This is a feasible solution. So we will update our rest to 4. But now can we move any further? That means our result is 4 and that is our answer. So that is how we have to solve this question. I hope you got it. Thank you.